Now let us see different type of thermometric scales. For industrial measurements, we use different scale. Suppose we have to measure weather, temperature, anything like that, melting point of water, ice, melting point of iron, and all these industrial temperature are generally expressed in Celsius or Kelvin. When we go to a hospital, we have fever, our doctor tells that you have 102 Fahrenheit. So we have a different scales in use. So these scales are used in practical purposes, so they are not so much precise. That means they don't take the triple point of water as a standard reference point. They take ice point and boiling point of water as the standard reference point. So suppose here is different scale name I am writing. Here this ice point value, ice point for that scale. This is steam point for that scale, and then number of divisions. So number one, suppose I say Kelvin scale. So in Kelvin scale, I will take ice point as 273. I will neglect that 0.15. So because these scales are not that much precise, they just take ice point as 273 and this is 373, and we have the whole scale is divided into 100 number of equal divisions. So number of divisions is 100. Next, second, Celsius scale. So it is reported in terms of Kelvin. We don't write degree Kelvin. For Celsius scale, 0 degree centigrade. So we say the ice point as 0 degree centigrade and the boiling point of water as 0 degree Celsius or centigrade, and again it is divided into 100 number of divisions. So now third one, Fahrenheit scale, that is used by doctors to measure this our fever, 32 degree Fahrenheit, and then it is 212 degree Fahrenheit, and the number of divisions is 180 degree. So these are the general scales. Other scales are there, but these are the common scales. Now we can convert. It is asked that if this much is centigrade, how much value, numerical value it has in Fahrenheit scale. Suppose I am having a fever here of 102 degree Fahrenheit, then what is my body temperature in Celsius? So we can change this. So suppose degree centigrade is written as C minus ice point by number of divisions is equal to here Fahrenheit minus ice point by number of divisions is equal to Kelvin minus ice point by number of divisions. So that is, suppose I say ice point is 0, so C by number of divisions is 100 is equal to F minus ice point is here 32, that is number of divisions is 180 is equal to Kelvin temperature minus ice point 273 by number of divisions is 100. So this is the formula by which I can convert a particular temperature in centigrade, I can express in Fahrenheit, I can express in Kelvin. This is how we can convert the different scales. Now let us take an example. What temperature in Celsius scale has the same numerical value in Fahrenheit scale. So we have C minus 0 by 100 division, F minus 32 by 180 divisions. So we have C is equal to 1 0 1 0 cancel. So this is 5 by 9 F minus 32. So suppose we want what value of C has the same value, that means C also, the F value is also C. So I will write 9C is equal to 5C minus 5 into 32. So this becomes 4C is equal to 5 into 32. So C becomes 5 into 8, that is 40 degrees Celsius. That means 40 degrees Celsius, if I will ask what is its temperature in Fahrenheit, will be equal to 40 degree Fahrenheit. So its value in Fahrenheit will be also 40 degree. So now let us talk about different type of processes in a thermodynamic system. So first of all, see what's a process. Process. What is a thermodynamic process? Any change in the thermodynamic coordinate of a system involves process. For example, suppose a gas we have, in which we plot here pressure and volume. So initially the volume is this much and pressure is, so initially it is at A and then it went to B. So any change in the state of the system involves a process. So process is what? Whenever there is a change in the state, thermodynamic state of a system, that's a process. So there are different types of processes. We will learn in thermodynamics, first law of thermodynamics, that we have constant pressure, then constant volume, isotherms, adiabats. So there are different types of processes. There are different types of processes. Presently we are not interested in which P and V changes. So we are interested in understanding, so reversible process and irreversible process. So if I can go from A to B and I can also come from B to A automatically, then it will be called a reversible process. But if I can go from A to B but I cannot come back, then the process will be irreversible process. So every day sun rises and sunset. So again it repeats. It's not a reversible, but it is a repeating process. Irreversible process, aging. When we are child, then again we will become young and then we will become old, but we can't go back in our time. That's a irreversible process. So the processes can be reversible and irreversible. Presently we are interested in studying what is quasi-static process. So quasi-static process. So suppose I am going from A to B quasi-statically. So in a quasi-static process, the system departs so slow, infinitesimally, that each time it passes through reversible equilibrium state. That means the system is carried out very slowly. So suppose I have to carry our system to A to B. So I will just move from A to C then C to D. So A to C, these are equilibrium states. These are equilibrium states. Intermediate steps are involved. Now suppose if I leave the system at C, the system can automatically come back at A because these are reversible equilibrium states. If I again from C to D, if I have brought and I release the system can come back to C but not to A. That means each time the system is slowly departed from its position A to B. Now the final process A to B may be irreversible, but when it passes through equilibrium states, they must be reversible equilibrium state. Then such a process is called a quasi-static process. So the quasi-static process is a very slow process such that each equilibrium state is a reversible one. This is the quasi. So unless stated in our whole thermodynamic study, which we will study in intermediate classes, unless stated, all the processes are assumed to be quasi-static. So in order to define quasi-static, we must know what is reversible, irreversible, and nearly all the processes which we will learn in thermodynamics will be quasi-static unless stated. So next, now let us see what do you mean by the term thermodynamic equilibrium, because I have used this point here that all the points here they are in equilibrium states. So what do you mean by thermodynamic equilibrium, we will see.